Now, software development life cycle, we need to be aware about that. We are not system admins, or we are not just cloud engineers who handles the infrastructure. We handles end-to-end delivery. Okay, I'll give you an example which generally give really makes sense. Um, it's an analogy. Think about you have a great idea of um, packaged food. Okay, you have a great idea that I can create such kind of packaged food which will be which is very tasty and everyone will like it and will have a very good business. Okay, great idea. Okay, and you also tested that idea among with some of your friends and some of the users or customers and they really liked it. Now you thought of setting up a big supply chain, your own production house that create that packaged food. Let's say it's nachos chips, if I spelled it correctly. Okay, nachos chips, and you have taken a lot of money from the market and you've set up a huge production uh, plant that creates that nachos chips packets. Okay, so everything is done there and you have set up the best of the plant, in the world. All right, the best technology, the best automation you did there in the plant. So it's creating that nachos chips packet. Now once the packet comes out of the factory, it has to be packaged into bigger packs, then has to be loaded into the trucks. The trucks has to go on the road and deliver it to the retail market, the malls and all. Okay, and in the process you have not only delivering it locally but nationally or probably internationally. So it has to go to trains and ships and has to be exported out of the country, right? Now, in this entire process, okay, please mute yourself. So now in this entire process, you know that your chips of the taste is amazing. Okay, the first batch comes into the market and people are really liking it. All right, and the idea also came into the market that okay, this kind of chips are very liked, very much liked by the people, and everyone wants to have it. So the idea also comes into the market along with the chips, right? Now the first batch comes, people liked it. Now people are waiting for another one. Okay, the stock is over now in the market. Now you are having problem in delivering that chips to the market because of so many reasons. Your logistics, your trucks drivers are not so good, your trucks are not so much efficient. Okay, the roads from your plant to the highway is very bad. Okay, your packaging of the product is not so good. Because of that, the chips are getting damaged. All right, because of all these problems, because of all this logistics problem. Okay, the chips comes into the market late, and plus when it comes the chips are broken. All right, so user maybe trying another batch, but by the time some other companies already got that idea, but their logistics is the best. They manufacture the package the chips and sends it very quickly to the market with similar taste or probably better than you. All right, and chips are in good shape. So when someone comes to buy your chips and don't find it and you find some another chips, they'll purchase that one, right? You put the idea into the market, but someone else is making the money from that now. All right, why? Well, your plant is the best in the world. All right, but your delivery process is very bad, your logistics is very bad. So my point is, it's not about creating the product, it's also about delivering it. In today's world, if you don't deliver the product properly and on time, you lose the business. No matter how good restaurant you're running and how tasty your food is, if you're not able to deliver it to the people, today's food delivery world, right? At home delivery, if you're not able to deliver it, you will lose the business. Someone else will get the business. Okay, now that analogy strikes. Then the same applies in the IT industry. We have a great idea of a software that we want to launch into the market, but if our delivery is very bad, even if we deliver, the product doesn't run properly because there's so many changes, so many manual intervention. So people may go for another app. Okay, people are nowadays, switching between different apps and liking some other apps. Tomorrow they like some other app. Okay, so my point is, delivery is extremely important. So who helps in delivery, making the logistics better? DevOps. You automate the entire process. Think about you're handed over the chips logistic to someone else. You just give them chips and they'll make sure it gets delivered on time and in perfect shape, right? So someone else is doing that headache. That someone else is you. So we are into logistics, like not literally logistics, okay, but the IT logistics. So let's talk about a traditional software development life cycle. Like I explained you about the chips, let's talk about the software now. So whenever someone have an idea, they gather the requirement uh, from that client or the customer, the business analyst and sales team. Okay, the requirement will be gathered, and then with all that requirement, it will be given to the developers to create it. So the developers are going to code for the software, okay, create the product and test it locally in their own machine. Okay, then they're going to build the code, deploy it to some development server where it will be tested again. All right. Once the developer feels that they have developed the right code, then it will be given, then it will be deployed to the tester's machine. Okay, QA guy, where the QA or quality analysis or software testers are going to test that product left, right, and center. Okay, they're going to test for the load, they're going to test for the functionality, and so many things. Once it checks out fine, then it will be given to the operations team to deploy to the production server and with proper documentation and all. Okay, and when it goes to production server, it has to be maintained. The server has to be maintained. The software has to be maintained. That's the responsibility of the operations team. Okay, so that's in brief. Okay, that's how the software development life cycle works, from gather requirement to delivering it to production system and then maintaining it, of course. Right. So far so good, but when you deploy code into production system thinking that it will work the way it was working in the development, okay, it doesn't work like that, right? Mm, yeah. So it fails. The deployment fails on the production system. Even we have tested in the tester's machine, the staging environment is tested, the development machine, it was tested, it was working all these places, but it's not working in production. And you complain it with the developers, but the developer says it works very well in our machine, but it's not working in your machine. That means the problem is with your machine, the production machine. Check that machine, not our code. Okay, who really knows? Production environment are mostly different than the pre-prod environment. Pre-prod environments are like staging, QA environment, developer environment. They are different. Okay, they don't have the same data as it's in the production. Okay, but this environment are not in sync. Plus the company will try to save some money and will keep the staging and QA environment very small, not multiple servers. But production will be multiple servers. Okay, database will be huge and all of that. There will be high level of security and high availability on production system that will be not there on staging environment and QA environment, or just to say pre-prod environment. Okay, because of that, the application doesn't behave the same as it was behaving in the QA environment. When you deploy, probably one service is not connecting the other service because of some network issues or firewall issues. Database may giving you different results because the data is different in the database. Okay, and these are some reasons because of that production deployment fails. So one solution can be, you can have similar environment, staging and production environment. All right. Plus, there's so many human beings who logging into the systems and making the changes. Sometimes they do it right, sometimes they do it wrong, because there's just going to be so many steps for the deployment. You will see when I take that session, there's so many steps to deploy that entire product, some human error. Okay, so that one issue. Another one is, before you solve this issue, the another code comes in. So the new deployment tools and development tools and the new process, agile and all, are making development very fast, but the operations is very slow. It's not able to cope up. Operations team needs to follow some process, ITL process. They need to take approval and all, so they can't make changes into the production system quickly. Okay, so the code development is faster, but the deployment is slow, right? So they're not able to handle the load. Also, production server, as I told you, need a lot of tweaking, okay, on the database, network, security level. Then only things runs properly. All right. And one more big problem is something goes wrong in the production system, then developers needs to be conveyed through mails. You need to send them logs and all. Developers don't have a direct access to the production system, and because of that, resolving that problem also takes a very long time. Okay, and there are reasons why they don't have access that I'll explain you later in security. Right. So you need some tool, technology, process that can solve all this problem, because if there's something that goes wrong into the production system, it's a business loss. Okay, now as I told you, before the code goes to the production system, before the software is deployed to the production system, there's so many things that happens, right? Before the chips comes to the supermarket, there are so many logistics and packaging and everything that will be done. Okay, in software development, pre-prod, whatever is happening, when the developer writes the code till it comes to the production, whatever process is there in the middle, building, testing, packaging, that process is called as release management. And you'll be surprised to know that 75% of the time spent by the operations team is in release management. You have to create servers for the developers, testers, right? Even for the customers, you have to maintain their database storage, and they'll be regularly sending you requests that make this changes, make that changes, because it's continuously changing environment, because they'll be continuously testing it. So 75% of the work of release of the time of operations team is spent on release management. That's 195 days of the year. Think about, you can automate that process. I'm not talking about production, before production. If you automate that entire process, the developer writes a code, clicks a button, and that entire process happens automatically. And the software is ready to be deployed on production now. And all you have to do, operations team, you have to take that and deploy it to the production. Production deployment will be also automating, but with approval, we'll execute it. Okay. So you'd be saving a lot of time, also a lot of money, okay, because you don't need that many people in the operations team, because if everything is automated. Okay, and whatever mistakes is done in the release management, okay, because of that 60, whatever failure that happens in the production system, it's because of the 60% of the mistakes that is done in the release management process. All right, so if you have a robust automated process where there is no manual intervention, all automatic, then it's going to give you the same result every time. Okay, so you're not only just saving the time, you're making sure so many mistakes, communication issues gets eradicated. All right, and of course there are a few more statistics that we'll talk about. Okay, just a moment. So I was telling you that nowadays operations team are not able to handle that much load. The developer keeps on giving new requirement, okay, new code changes. Operations team are not able to deliver all of them in that rate. Okay, so, and this process was the same process was there for a long time, this traditional deployment. So what happened now? So let's discuss about it. The world has changed, the development has changed, but the operations team has not changed with that. Because of that, all these problems are coming. Okay, I've explained this in the demo also. It's there in my book also. You have to read the first chapter of the book, people, everyone. I hope you got the link, or if you did not get the link, you'll get the link today in the starter kit. Download the book, read the first chapter. You need to understand the process. Once you understand the process, then what a tool I will teach you, you will be able to correlate that this tool will be implemented at this place. This course is complete practical course where I'll try to put more and more process in your mind also. Okay, but you have to do some reading also. And so read the first chapter of the book, understand the process, understand the problem. How do we solve that problem? By using different tools. Okay. So I explained this in the demo also. We have no, so sorry, the developer have a traditional development life cycle, which is called as waterfall model. They follow this model and develop the code and deliver it to the respective team. So waterfall works like this in phases. First phase, you have requirement analysis. So first, all the requirement will be taken, okay, for the entire product. You're developing, let's say, an e-commerce website, web application. So all the requirement will be taken from the customer or the client. Once you have taken all the requirement, then it goes to the design phase. Okay. Then the architects will design everything. Will design the software, database will design the database. Operations teams, architect will design all the infrastructure. So all the design documents, everything will be created for the entire product. Once all the designs are ready, it will be passed down to the development. Now development have the complete roadmap of what they have to do, and they'll start coding. Okay, so they'll develop the entire product, probably in different modules, but the entire product will be developed. After the complete product is developed in few months time, then the product is passed down to the testing team. Testing team, QA, also we call them, they are going to take the product, and with the help of the operations team, they'll deploy it to servers, and then they will start testing it. Functionality test, load test, TB test, this test, that test, lot of tests. Once it passes all the tests, then it will be moved to the production where it will be maintained for a long time. Okay. Any of the process testing fails, it comes back to the development team that we need to fix. This is the problem, fix this problem. So this is a waterfall model which is into phases, and we work on everything at once here. Okay. Now this model is not